This is Mr. Anderson for Kellogg Community College. We're going to be looking at Section 1, the second part video here, and we will be looking at inverse functions of themselves. When you went back to Math 121, we learned that if you take any function and its inverse and put one inside of the other, you would always get x as your answer. This is actually one way to check to see if you have a function or not. So if you take the function put its inverse inside of a function, or the function inside of its inverse, what will happen is that you're going to get x when you do your simplification. Without actually going back to review all the Math 21, I strongly recommend that you go and look at Chapter 8 videos for chapter of Math 121 or Chapter 9. So there's some good examples there. What we're going to do here is we will take a look at a table here that we'll use on we'll use it for figuring out the inverses and these exact values here for when we have the inverse of any given function. And we're also going to look at the function of any given inverse. Now the answer to both of these would be x, but these can give us different things when we're trying to see what's inside of them. So I'm going to put some little wheres here. So for the first part, we're going to take a look at when we take the inverse sine of a sine of x function to give me x. What's important to know is that there's a certain boundary for our answers. We're going to be looking in either the first or the fourth quadrant for these, for my x values. And again, we'll go down here for the sine. This is going to be cosine -1, or the inverse, sorry, not -1. It's not an exponent. The inverse cosine of cosine is going to be x, and this is going to be between 0 and pi. And then finally, the tangent, inverse tangent of the tangent function of x is also going to be x. And similar to, but not quite like, this inverse sine function, this is going to go to, but not include, -pi/2 and pi/2, or from -90 to 90 degrees on the unit circle. So what this is going to do is we're going to evaluate what is the answer to these. And normally you just take the thing on the inside, but this value on the inside has to be between this given range. And in this case, -pi/10 is between -pi/2 and pi/2. So therefore our answer is -pi/10. See, as long as our answer is within inside of its bounds, we don't have to do any kind of trickery to get that problem to work. -3pi/7 is also between -pi/2 and pi/2, so we're going to keep that answer the same. But this is an example here. This cosine, this -5pi/3, is not between 0 and pi. Now what I'm going to do is create a unit circle here for this, and if I go -5pi/3, that takes me all the way back around to the first quadrant to pi/3. So even though this is the right location in there, this wouldn't be the way we would write our answer, because our bound has to be between 0 and pi. So our answer would be pi/3. This last one's a little tricky, because when we look at -2pi/3, and we draw a unit circle here, -2pi/3 is actually pi/3, and then 2pi/3. So it's kind of over here, this angle right there. And what we need is an angle here in the first or the fourth quadrant, because we have to be inside of this x value domain for this problem. And the one angle that matches that, now we've got 4 of them. We've got one here, we've got one here, and we've got one here. So this is the pi/3, This is 2 pi over 3, 4 pi over 3, and 5 pi over 3, you know, in the counterclockwise way. This is the one we're going to want right there, because that puts us inside of the correct zone for our x values. So this answer is going to be pi over 3 as well. So that is our answers there. Now what I'm going to have to do is fill out the rest of this table and then go below. Go actually, you know, kind of push this up here. So you're going to want to write this down and then move this up and, you know, see what, you know, just kind of keep checking back and forth on it. If I start out with taking the sine of the inverse sine function, I'm still going to get an answer of x if x is between -1 and 1. And if I take the cosine of the inverse cosine function, this is also going to have to be when x is between -1 and 1. Tangent of the inverse tangent of x has no such restriction, because as we saw on the previous side of our worksheet, x can be any value. So you would just write down the value for your tangent functions. Now again, please copy this down because I'm going to need to move to the bottom of this worksheet here for the end of my worksheet, my video. And pay attention to the instructions, because it says find the exact value, if any, of each composite function. If there is no value, say not defined. Do not use a calculator. So -2/3 for my cosine is between -1 and 1. So like my answer of that being x, it's within the correct boundary, so it works. Tangent has no such restrictions, so we can easily put down -2, because -2 is between negative and positive infinity. -2, though, is not between -1 and 1, so this is not defined. And -1.5 is also not between -1 and 1, so like the one before it, it is not defined. All right, thank you very much.